So part one is asking us to find on the 3 throws of this dice, what's the probability that I get no 6s from those 3 throws. Now a dice, as we know, has 6 segments, and on one of them is a 6, and on the other 5 there are no 6s. So the probability of not getting a 6 is 5 out of 6 on my first throw. And my second, so multiply by my second throw, which is also independent, so it's 5 out of 6. And on my third throw, it's also going to be probability of 5 out of 6 for no 6s. And when I multiply them, I'm getting 125 over 216. If you want to turn that into a decimal, so it's might be easier to visualize what that stands for. It stands for 0.58, which is 58%. So if you have 58% chance of not getting a 6 when you throw a dice 3 times. So that's part one. Looking at part two now, it has those key words in it, which are at least. So think about this for a second. So at least 1 6. That means I can get 1 6, I can get 2 6s, I can get 3 6s, I can get 4 6s, I can get 5 6s, and I can get 6 6s. So at least 1 6 is the opposite of getting no 6s. So what I'm basically doing here is I'm taking the full probability, which is 1, it's 100%, on my probability scale it's 1, which is 6 over 6 basically, and I'm going to subtract the probability of not getting a 6. And that's my answer from part 1, which is 125 over 216. And when I subtract 125 over 216 from 1, I get 91 over 216. And as a decimal, it's 0.42. So about 42% of the time, I will get at least 1 6. Okay, so keyword there, at least, means 1 minus no 6s. Part 3 now gets a little bit trickier. What's part 3 saying? Exactly 1 6. So again, don't forget that we are throwing our dice 3 times. So exactly 1 6, you could have many orders for this. So what you could have is, I could have, on my first throw, I could get a 6. On the second throw, I could get something else. So I'm going to say other for a 1, 2, 3, 4, or 5. And on my third throw, I could get something else or something other. So that's one possible scenario that I could have. Or I could have not a 6 on the first go, so something other than a 6, followed by a 6 on my second throw, and then on my third go, my non-6 again. So remember that you are looking for exactly 1 6, but that 6 can come on the first dice, or it could come on the second, or it could come on the third. So I'm going to do it out again. Or I could get something other than a 6, something other than a 6, and then finally on my third go, I get the 6. Now I have to turn that into probability. So the probability of getting a 6 on a dice is 1 over 6. And on my second dice, I get something else. So that's 5 out of 6. And on my third dice, I get something other than a 6, which is 5 out of 6. So a 1, a 2, a 3, a 4, or a 5. So it's a 6 and something else, and meaning once again to multiply. So I'm putting a multiply symbol between those 3 fractions. Just going to put them in a bracket. Now we have this or symbol. Remember that or in probability means to add. So it's a 6, not a 6, not a 6, or plus the next scenario, or the next scenario. So I have to go through all 3 of them separately. And when I fill them in, they're basically going to give me the same answer. It's 5 over 6 for other, multiplied by 1 out of 6 for getting my 6 on my second, and I get a other than a 6 on my third go. And I do that then for my third throw of the dice. So I'm throwing this dice 3 times, remember, so I can get a 5 out of 6 and 5 out of 6. So that counts for a 1, 2, 3, 4, or 5. And then on my third go, I could get that famous 6. So 1 out of 6. Now when I multiply 1 6th by 5 6ths by 5 6ths, I get 25 over 216. Now that's the same for all 3. So it's plus 25 over 216 plus 25 over 216. So I get the same answer for all three scenarios. When I add them together then, we get 75 over 216. So when I add them together, 25 plus 25 plus 25 is giving me 75 all over 216. Now, if you want, you can simplify that down. That will simplify to 25 over 72. And if you want, you can turn it into a decimal, which is giving me 0.35. So about 35% of the time is when you would expect to get exactly 1/6 when you roll those three dice. Okay, so that's part 3. Looking at the final part here, so I'm going to call it part 4, so IV here, is asking us to now find the probability that the 3 throws all show the same number. So they all show the same number. So let's think of that for a second. So I'm throwing my dice again 3 times, okay? Now, if I was to look at it like this, I'm going to draw out my 3 dice. So this is my 3 goes of throwing the dice. Now, on that first throw of the dice, it doesn't matter what you get for the first go, because the question is asking that we get the same number on all 3 goes of the dice. So my first throw of the dice is irrelevant as to the number that I get. If I get a 1, happy days. If I get a 2, 3, 4, 5, 6, it doesn't matter. So I don't need to put a probability into that first box. I'm just going to put the number 1, which stands for 6 over 6. I can have any one of those numbers to land on that first dice. So that 1 there represents 100%, not the number 1 on a dice, but 6 over 6. So I can get any number on that first dice. But now we're going to look at the other 2 dice. If I get, let's assume I got a 3 on that first go of the dice, I then need to get the same answer on my second dice. So again, assume that I got a 3 here for my first dice. What's the probability now that I get a 3 on the second dice? It's going to be 1/6 because there's only 1 3 on the dice. And I roll that dice again. I again want to get a 3, which is 1 over 6. So what I'm basically doing is my first dice, just to recap on this, doesn't matter what you get. But the second and third go, I must get whatever I got on that first dice. And when I multiply 1/6 by 1/6 by 1, I get 1 out of 36. Thank you for watching another tutorial video from Tulla Maths. Make sure and subscribe.